The 15th Engineering International Conference 2026. Comparative analysis of costs and emissions of high-volume fly ash self-compacting concrete. Introduction. The need of concrete as construction material in infrastructure development increase. In the making process of structural concrete, Portland cement is the main determinant of the strength of concrete. The Portland cement in its manufacture requires a large amount of energy, and at the same time causes environmental pollution. In the last few decades, the technology of concrete materials for construction has developed. One type of concrete being developed is self-compacting concrete, SCC. Self-compacting concrete was first developed in Japan around 1988. The main characteristic of SCC is its ability to flow and fill the mold and pass through the reinforcement independently without the intervention of external energy. This kind of property is possible because of the moderate viscosity, which is determined from the proportion of the mixture with a higher content of small particles compared to normal concrete. The high proportion of small particles causes the cement content in SCC in general to be higher than conventional concrete. The manufacture of 1 kilogram of cement, the amount of CO2 emissions is equivalent to 0.9 kilograms. A practical step to maintain environmentally friendly concrete manufacturing is to reduce the amount of cement used. One method to reduce the use of cement is to replace some of the Portland cement with fly ash. The cement replacement with high amount of fly ash has been carried out for a long time, even at replacement levels of more than 50% as known as high-volume fly ash concrete, HVFA-SCC. Research aim. 1. Analysis the costs and emissions of normal concrete and HVFA-SCC. 2. Compare the costs and emissions of normal concrete and HVFA-SCC. This study will provide a comprehensive overview of the potential cost savings, carbon emission reduction contributions, and the feasibility of implementing HVFA-SCC in construction projects, particularly in developing countries like Indonesia, which has abundant fly ash supplies. Mixed design of normal concrete and HVFA-SCC. For NC sand 870 kg per cubic meter, gravel 940 kg per cubic meter, cement 450 kg per cubic meter, and water 180 kg per cubic meter. For HVFA-SCC sand 876 kg per cubic meter, gravel 635 kg per cubic meter, cement 275 kg per cubic meter, fly ash 275 kg per cubic meter, water 176 kg per cubic meter, and superplasticizer 5.5 kg per cubic meter. Fresh concrete test of HVFA-SCC according to FNAC 2005. Slump flow test, the requirement 650 to 800 mm, T50 slump flow, the requirement 2 to 5 seconds. L-shape box test, the requirement H2, H1 equals 0.8, 1. V-funnel test, the requirement 2 to 5 seconds. Fresh concrete test results. Slump flow test 670 mm, T50 slump flow for 0.65 second. L-shape box test 0.86. V-funnel test 9.1 second. All HVFA-SCC test fulfill the requirements. Compressive strength test results. For NC the average compressive strength is 31.8 MPa. For HVFA-SCC the average compressive strength is 33.12 MPa. The compressive strength of both types of concrete is nearly the same and meets the requirements for use in structural work according to SNI 2847, 2019. Cost analysis. Cost analysis was conducted to determine the manufacturing cost per M3 of concrete, both for normal concrete, NC, and HVFA-SCC. The total concrete cost was calculated by multiplying quantity of material with the unit price of the each material per meter cubic. From two tables it can be seen that to make 1 meter cubic of NC, it requires a cost of IDR 9 for 5500. While for HVFA-SCC per meter cubic, it requires a cost of IDR 787700. The difference in the cost of making NC and HVFA-SCC is IDR 157800. The cost efficiency obtained when using HVFA-SCC is 16.7%. Emissions analysis. Emission analysis was conducted to determine the amount of CO2 emissions produced in concrete production per cubic meter. The total emissions was calculated by multiplying quantity of material with the emission factor of the each material per cubic meter. The emission factor used data from a Designer's Research 2020. The CO2 gas emissions produced in normal concrete, NC, are 446.078 kg CO2 cubic meter, while in HVFA-SCC it is 283.766 kg CO2 cubic meter. The difference in emissions produced by the two types of concrete 162.312 kg per cubic meter. Furthermore, it can be concluded that implementing HVFA-SCC will reduce CO2 emissions by 36.39%. Conclusions. 1. HVFA-SCC can achieve compressive strength equivalent to NC, so it can be applied to structural work. Fresh concrete testing also shows that HVFA-SCC meets the requirements of self-compacting concrete. 2. HVFA-SCC provides significant cost saving. Substituting 50% of cement with fly ash in the HVFA-SCC mixture results in a reduction in material costs of around 16.7% or IDR 157800 per m3. These savings mainly come from reducing the use of cement, the most expensive component of concrete mixes, as well as from reducing the need for superplasticizers. 3. HVFA-SCC can drastically reduce carbon emissions. There is a 36.39% reduction in emissions, making HVFA-SCC one of the most environmentally friendly concrete choices for modern construction.